Hello, I'm Ryan from High Desert Math Tutor, and today I'm going to show you how to multiply and simplify rational expressions. So before we begin, you need to remember that rational expressions are just fractions. They're fractions that have polynomials in the numerators and in the denominators. So the easiest operation you can do with fractions is multiplying, because you just multiply straight across the numerator straight across the denominator. That same idea holds true for rational expressions, but when we're working with fractions, and especially when we're working with rational expressions, before we multiply, we generally want to make our lives easier by simplifying each expression before moving forward. Now, anytime we're working with rational expressions, we generally want to make sure that we know what the domain of the functions are, or the function overall, which means we ask ourselves first, are there any values that we could plug in for the variable? In this case, the variable is a. Are there any values that we have to avoid using, that we're not allowed to plug into the function, otherwise we could break it? So the only thing we generally cannot do with rational functions, just because they're fractions, we cannot divide by 0. So we have to look at all of the denominators and ask ourselves, what values could we potentially cause this denominator to turn into 0 with if we use? So what we'll do is we'll start by finding what values we're not allowed to use for a, by taking each denominator and setting these denominators equal to 0. So this one's really plain and simple. So what could we plug in for a so that a becomes 0? We just plug in 0. But again, remember, we're not allowed to divide by 0, so a is not allowed to equal 0. Similarly, over here, 5a plus 5 is not allowed to equal 0, and we can figure out what value for a makes that happen if we solve for a now. So subtract 5 from both sides. We get 5a equals negative 5. Divide by 5 on both sides. A is equal to negative 1, which again, those are values that we are not allowed to use. So these values are restricted to us. And more generally speaking, those values for a are not in our domain. We are not allowed to plug those values into the function. Now that that's clear, we can move forward and going ahead and just simplifying each rational expression, and then we'll just multiply. So to begin, we want to ask ourselves, is there a greatest common factor in the numerator and denominators of each of these functions? If there is, we want to factor that out right off the bat. So in this numerator, all we have is 5 times a. In this denominator, this term has a 5 and an a. This term has a 5, so both terms have a 5 in common, so we can factor out the greatest common factor, which is 5. So take out this 5, and now we ask 5 times what is 5a? Well, 5 times a is 5a. This is plus, so we're going to keep the plus. Now we ask 5 times what is 5? 5 times 1 is 5. So that's it for factoring this first rational expression. Bring over the multiplication, bring over the division bar. Now we ask, what's the greatest common factor in the numerator over here? So this has a 10 and it has an a. This term has a 10, so both terms have a common factor of 10. So 10 times what is 10a? It's 10 times a. Plus, because this is a plus. 10 times what is 10? 10 times 1 is 10. And now we see over here, we just have a single factor of a. So now that we've factored out the greatest common factors, if we could factor anything else any further, we would now, but this is factored completely. So what we can do now is ask ourselves, are there any common factors in the numerator and in the denominator? So we can see right here, we're multiplying the numerator by 5 up there and the denominator by 5 here. so those 5's cancel. We're multiplying the numerator up here by a and the denominators by a, so those a's cancel. And finally, the denominator, we still have a factor of a plus 1. The numerator has a factor of a plus 1, so those cancel. So nothing is left in the denominator. If we wanted to, we could technically say 1 is left in the denominator, but anything divided by 1 stays the same. So the only factor left is the factor 10 in the numerator. So this entire rational expression simplifies simply to 10. So again, in this case, it may not seem necessary to find out what the domain of this is. We haven't explicitly stated the domain, but we did kind of the minimum work by figuring out which values are we not allowed to plug in for the variable. And that's a good habit to be in, because when you're solving rational expressions for particular values, like what makes this equal 5 or what makes this whole thing equal 100, the most common mistake people make is forgetting to find values that are restricted, and when you get your final answers, you end up overlooking extraneous solutions. So even if we're not explicitly solving this equation or this expression for a value, it's always best to first find restricted values, then you can proceed to do any work you need to do with the expression in simplifying or solving.